and, and turn it over to Zach.
Thanks. Can you see the slides on the screen? Because
We
they're showing
can.
mine. Okay, cool. Cool. Yeah, thank you, Shannon, for that introduction. Very, very flattering introduction. I appreciate that. Like she said, my name is Zach. I am a PhD student in criminology at George Mason. I will finish one day. That day is not today. And through that process, I became very applied in my career, as Shannon mentioned. And that got me into exploring lots of ways that you can use your social science PhD to do things that are not academic. And this is the AltAc group, which means that's basically why we're all here. But that also got me more embedded in the technology sector and got me exposed to this growing field that is called data science that means a million different things to a million different people. But what I'm going to talk about today is kind of what this is, if you hear that word, and where it is, and why there's so many social science and honestly hard science PhDs who are transitioning into this, and then what the skill connection is between the two and the types of problems we solve. And we'll do some examples together in here. So I think, let's see if it lets me. There we go. So yeah, I'm a lead data scientist at Newspire. It's a cybersecurity company. I run our data analysis and R&D group there. If you want to see my awesome political rants, you can follow me on Twitter. If you want to keep things professional, you can connect with me on LinkedIn. Either one is fine by me. So if you've ever heard the term data science, it's probably been in one of these contexts. HBR posted this very famous or infamous article in like 2012, calling it the sexiest job of the 21st century. And then currently on US News and World Report, if you go to their best jobs, it is number 3 in technology jobs, number 6 in their 100 best jobs, number 6 in STEM jobs. And there's a host of reasons for that. Pay is one of them. It's attracted a lot of people like us who wanted to do science, but do science in a slightly different way than academia, and it's given them the opportunity to do that. And it's also, for a lot of organizations, been an avenue by which they can unlock a lot of knowledge and insight that otherwise would have just been kind of sitting in databases doing nothing. And so that's what we're going to talk about today. But yeah, if you've heard this term, you've probably seen these things, and no one really knows what this term means because it's not self-explanatory, right? If you say that you're a criminologist, people have, oh, okay, you do something with crime. If you say, oh, you're a psychologist, people are like, okay, you do something with psychology. If you say that you're a biologist, people start ranting about COVID to you. And everyone kind of has an understanding of what those things are or are not. But this is one of those fields that even people in the technology sector tend to not quite understand because it's grown over people who have been trying to take scientific skills in other domains and now been like, hey, we have all this data coming from technology. What do we do with it? And that's really what's driven this over the last 10 years. This field has even grown over the last 10 years because it's a very new thing. It's because of just the amount of data that's everywhere, right? Every business collects data on their customers, collects data on their operations, on their employees. Every app you use on your smartphone collects some kind of data about what you do. And there's privacy concerns baked into all of that. But the reality is, within all of that is tremendous ability for us to understand ways the world works. For an organization, you can understand a lot about your company culture and your people and how you're doing as an organization through your HR data. And you can also learn how to do your business better through your customer data. From a more like, I guess science for good standpoint, stuff like contact tracing for COVID-19 and some of the initiatives around like tracking police brutality have come out of people leveraging data from smartphones and apps and this kind of wealth of big data out there in a way that has allowed us to unlock understanding about social phenomenon and unlock understanding about how humans work. And in that, there's a host of ways you can go. There's the pure research side of like, this is just really interesting, and it's a way to use technology to grow social science. That's a whole avenue here. There's also the business capitalist version where it's, hey, we can make our business better and we can sell things better and we can sell better ads, kind of like what Facebook and Google use a lot of their data for. And that's all fine too. At the end of the day, all of these things are applied versions of all the skills that we learn in a social science PhD or even a hard science PhD. They're just used in a technological way. So to get at that, this Venn diagram is hated by almost everyone at data science conferences, but I'm using it anyway because I think it makes my point. And so really what data science is it's the intersection of these three things. Now, if you'll notice, the math and statistics and the domain knowledge overlap to create traditional research. That's where all of us already sit. The day you start your master's or PhD program, that's where you sit. Right? That's where most of our professors sit. That's where many of those of you who are in here who work in AltAc jobs probably still sit, right? Even though you're not in academia. That is what we're trained to do. The only thing that data science adds is this technological component to it, right? Which is really not all that extra when we'll start to break down what actually gets added. And historically, that technological component and the math and statistics we've all learned, linear regression, logistic regression, has combined to make the offspring that is machine learning, if you've heard that buzzword, or AI. And we'll talk about a little bit of what those buzzwords do and do not mean in a minute. But that's kind of their brainchild. And then even more historically, computer science and just good old understanding the domain you're in has been what's led to software development. That's what people use to make apps that do all kinds of things, right? Data science is this nucleus in the middle where we are saying, what if we took the technology that exists to unlock all of this data and do this at scale, combined with the math and statistics that's been really proven to help us create scientific insights, combined with our knowledge about a certain domain. In most of our cases, it's going to be something in the criminology, homeland security, criminal justice, social justice realm. If you can combine those three things, then there's just a wealth of insights that can be unlocked. There's all kinds of new questions we couldn't previously answer with traditional social science means. Our kind of base standard of n equals 100 that we use in social science goes out the window when you're talking about n equals 2 million, 3 million, or even a billion. I've had some projects where we've had over a billion rows in some of our models. That's only unlocked because we've added this kind of newer technological component that brings different skills and complexity to the problem for sure. Now, level set here. When you see the word machine learning, because it's going to come up in data, if you search data science anywhere, you see the word, it is just statistics at scale. That's it. And this is one of my favorite memes about that, of the little frame. Statistics, put a frame around it, try and sell it for an audience. It's machine learning and AI. Under the hood, when you see people are using machine learning, I'm willing to bet it's almost always logistic regression, something you already know how to do. And when you even very complicated things like the computer vision, where your iPhone knows that this is a coffee cup kind of stuff, is based off of applied methods that are essentially networks of logistic regression models analyzing that image converted into a matrix, right? At the end of the day, it's nothing really different than what you've probably done as part of your master's thesis and or dissertation, to be honest. It's just done at scale, and it's done with slightly different tooling. So I say that to level set of, this is a scary word. And a lot of times when I've helped coach people who want to move over from a social science or policy science domain, and they want to get into more data sciencey, and they see these jobs, they look like really cool problems to solve, and they see things like, oh, machine learning, like, I don't know nothing about machine learning or AI. That sounds really complicated. It's not. You already do know it. There's lots of great resources out there for you to kind of unlock what you already know in that realm. So kind of level setting there. So I'm going to start, before we talk about how you transition and what are some job and all the like basics of the job market, let's talk about some examples of like what a data scientist would work on and make this less abstract. So first, this is my favorite interview question. I use it anytime I interview anybody. And perhaps let's say we have a shoe store that's about to release a new line of shoes, and their sales leaders just want to know which customers are most likely to buy that new line. And they already keep a database of all of their previous customers and their customer information. Now, all of us being trained scientists would know that it's probably not enough to bank millions of dollars on just going in there and doing some ad hoc quick analysis. You want to be more rigorous than that. In the same way, we would tell a police department to be more rigorous than just doing some quick crime numbers about whether or not their policy worked or not. And you wouldn't want to isolate confounding variables, and you want to be more precise than that. You would also want to do that when you're making really big business decisions. So we would look at this and say, could we do some more rigorous statistics? Could we do some quasi-experimental work on this? Could we build something like maybe a linear or logistic regression and control for as many features as we can think of in our data we have? what features of the data are there that we could use to help control for possible confounding variables and get a sharper prediction. All of this is thought process that we all use already for all of our work. It's the same thing. Only difference here, you're not how do I make or did this policing policy reduce crime? You're saying, can I sell more shoes to these people? And that is very different. And kind of selling out, not gonna lie. And that's where a lot of people start hearing like it's kind of selling out. It is, not gonna lie. But through this, there's tremendous abilities for organizations to be leaner, spend less money, there's more job opportunities, and sometimes you can pivot to interesting problems. Now, I don't personally work on selling shoes. I work on more homeland security, cybersecurity problems that are much more aligned to what we got our degrees in, right? But some people just like doing the science part and don't care what they work on. And there are thousands of jobs like this out there where you just want to go study whether or not you can predict who's likely to buy shoes and save a company millions of dollars and they'll pay you hundreds of thousands of dollars to do it, go for it. Right? Those jobs are everywhere out there. And it's a direct application of the degree that you've all gotten. And if we sit here for a minute and think about this, or any of us think about this, you could probably let your little social science brain run on this and think of all different ways you would want to study this, or think of ways you would model this, or think of data you would want to add or collect, or see if it's already in the database to answer this question, because that's what we're all trained to do already, right? In ways that an MBA never could, right? In my opinion. So, some example areas. In data science, you build a lot of predictive models, right? As opposed to explanatory and exploratory models, we focus a lot more on predictive models. Can I take a dependent variable that's of interest to the organization that I work for and take data we have or collect new data or build data around in a way that allows me to predict that reliably? Whether that's through predicting group membership in like a logistic regression setting or predicting an outcome in a linear regression setting, it's just taking that and focusing on prediction. When you do that, your concerns change a little bit. I'm less interested in the statistical significance of my coefficients in the model as I am in the accuracy of the predictions of the model. And sometimes I'll make a different trade-off than I would if I was submitting to a journal article in which the first thing they're going to ask me are any of your coefficients statistically significant? Because in that case, we're trying to explain something about the universe. In a data science perspective, I'm just trying to see if I can reliably predict this outcome. And in that situation, the things that I use to tune my model and assess whether or not my model is a good fit and the way I describe and talk about it are very, very different. But again, if you've used linear regression before, if you've used logistic regression before, you've used these techniques. They're not new. They're nothing that you haven't been trained on. It's just applying it in something slightly different. And to be honest, when you hear about big, bad, scary tech predicting ads and you get targeted ads, it's just this. It's under the hood, usually some kind of logistic regression or linear regression model that is just predicting what ad you're most likely to subscribe to, and through that, the data. Now, again, privacy concerns abound in the fact that that is a thing that's out there. But I use that as an example just because it's something we all interact with all the time, where we get the ad that's like, oh, that's exactly what I was just thinking I needed. Why do they know that? It's probably just logistic regression under the hood. It's something that you already know. It doesn't have to be something that's mythical and magical. We also do a lot of experiments, actually, believe it or not. I have done more experiments in data science than I ever have in criminology. And a lot of that is just because of the context by which you're able to do them. Testing the efficacy of programs and policies in an organization, testing software features. And we do this through a couple ways. A/B testing is a big one. And we're using that now in my work, where testing whether or not something improves the ability of a cybersecurity analyst by what they're shown on screen in a dashboard. And so by randomly assigning who gets to see a certain feature and who doesn't, and then looking at the outcome measures we care about on the other end, through that randomization, we've done a randomized trial. And we have the same internal validity that you would get through some kind of causal randomized trial in a public policy setting. The only difference is what I'm improving is very, very minute. It's whether or not this one little software feature actually improves our ability to respond to some kind of threat. But it's a controlled trial in the same way that you would, we all say is the dream thing that scientists get to work on, at least in a quantitative sense. And then also a lot of hypothesis testing and some other, kind of more basic experimental stuff. But I say this, use this example of a lot of times in especially the policy research realm, We're not able to experiment for a host of ethical concerns that we're all well aware of. We're not able to experiment and do randomization in the real world, but there's actually a lot of really awesome places in more of a technology data science perspective where we can do really good randomization and more rigorous science. And there's a host of places where you can explore that. I have also been able to do randomized experiments on like phishing emails where we will randomly assign various types of phishing emails internally to see who clicks on them and test for various ways that those phishing emails are responded to. That's human subjects research. Don't worry, there was a IRB-like committee that approved that before I was just able to randomly send spam to people's emails. But in that, it's just a randomized trial. It's the stuff that we all learned in Research Methods 1 when we started our PhD programs or master programs, whatever level you're at. Same stuff, just a different setting. And then we do a ton of exploratory analysis, right? A lot of times there's just databases of existing data, and your good old MBA type folk walk over and say, I want to know how many of these happened. And you just got to quickly run those numbers real quick. A lot of that, a lot of descriptive linear regression of just saying these things move together in ways that not unlike what we do in social sciences, but stuff that's not quite as rigorous as what you would submit to a journal article or anything like that. A lot more basic stuff, but this makes up a lot of the job as well. Some pretty low level exploratory analysis, putting together some charts to represent the data as it already is, or the data we collected, things like that. One thing that I think is important to understand about these things is a lot of it's the pace at which we put stuff out. So where you might take 6 months to a year working on a grant funded research project before you ever even start writing the paper, because you're just collecting data and analyzing data and reforming hypotheses. In the data science world, especially if it's data that already exists, it can be a few weeks of just analysis, putting together a model, putting together a report, et cetera. Because a lot of that's the data already there. The problem is very specific and it's very limited in scope. We have a very clear direction we're trying to go in, problem we're trying to solve, et cetera. And so that can also, some people see that as a win, because if you like to just work on stuff and move on to the next thing, it's a place where you get to do that more in these types of jobs. And if you want to just work on one thing and study it to the end for the next 3 years, probably not quite going to be the role that you enjoy. So what am I currently working on as an example? So my research focus right now is on how we can detect anomalous behavior on computer networks, right? So we've all done the whole thing where you log into a company computer, it says everything you're doing is monitored. That data all comes typically back into central repositories in a security setting. And through that, obviously, you're seeing all kinds of data about what's occurring on company computers and company servers and company networks. But the problem for a security setting is that by the time the hackers are already inside your organization, it's too late. And so we want to be able to, or by the time you realize they're in your organization, it's too late, because they've probably already stolen your stuff or locked your stuff down or ruined all of your stuff. And so we want to know, can we look for stuff that is abnormal that would be predictive of possible existing intrusions? And there's a lot of things to consider that we're considering in this. First off, how do you define weird? Because is it just the types of websites people go to? Because the second you hire a new employee who has a slightly different food taste than everybody else, it's going to look weird because they're going to different food websites. So that may not be rigorous enough. Is it certain types of emails that are being sent, et cetera, et cetera, et cetera? How do you define what's weird in the data? And so we're using Poisson mixture modeling, which if you've ever studied anything in criminology, you've probably seen this applied in journal articles abound. It's used in a lot of the age crime stuff. It's used in the crime and place stuff. And so we're applying this to detect kind of latent groups within it. And looking at the rates by which certain triggers appear, by the way certain events appear in the data. And this all sounds pretty, okay, that's basic, but we're talking about at any given one time, 600 to 700 features in our model, input variables, independent variables in these models across billions of observations, data sets that are so big your laptop can't just open these things, and SPSS would say no if you tried to. And so we obviously have to compute them slightly differently, but it's just giant models where we're assessing a lot of these input features and looking at how the distributions might differ, and then how we can use that to detect statistical anomalies. And then looking at how different organizations group along things. So instead of organizations grouping by their industry, or instead of organizations grouping by maybe the type of work they do, we're exploring how along these different features they might follow similar distribution patterns. And that's a classification that is baked into how they appear on their networks. And that is different and more applicable for us for understanding who's most at risk. Because if there's a breach, and let's say it's at a name big automaker, and they're breached, that doesn't necessarily mean all the other automakers are at risk, because the risk for the situation is much more based off how these companies operate, not what they make. And so by doing this, we're able to say, hey, you guys had this issue. Here's a bunch of other companies along these 700 dimensions or so that have similar distributions as you, and we think that they're probably also more likely to be at risk. And so the output of all of this, while it's interesting research, and obviously we have to write up internal papers and all the stuff that scientists have to do, these models are actually eventually just going to get embedded by our software engineers into software tools that cyber analysts will have access to this kind of knowledge and understanding, and it'll run on its own in the background. So that's the research that I'm working on. And you can see, again, the thing I'm harping on this whole time, while this is in the tech sector and it's using big data sets and tech tools, I'm describing what I could also probably just stand up and present this at ASC, right? And it would fit right into the stuff that we already talk about in criminology and homeland security. Or I could present it at pick a research conference, and this stuff would fit right in. It's not that we're doing anything drastically different than what you're used to in a science or research setting. It's just the goal. Instead of trying to create journal articles that will go on to inform theory and practice, I'm creating these models that'll get embedded into a software program that will go on to help cyber analysts day to day kind of assess risk for organizations. So that was work that you can do. Okay. And at this point, you're either, hey, that sounds really interesting. How would I break into that? Or this is cool, bruh, but it's not for me. And that's fine. Either one of those paths is up to you. For the first group, if this is something that you're interested in, let's talk about types of jobs and how you would pivot into this kind of work. So there's 4 types of roles in the data science sector. You have the data scientist, right? That's the kind of the standard role. Performs robust scientific analysis, does hypothesis testing, builds statistical models, et cetera, et cetera, et cetera. There's also a lot of roles for kind of a data analyst, which is usually kind of like more of a junior. That's the person doing much more simple analysis. They're usually just kind of doing some basic data aggregation, some queries. They'll help collect data, neaten up the databases, et cetera. I akin this more to kind of, if you're in a university setting, a lot of times what the undergrad research assistants typically do, or the bachelor's level research assistants do. Much more basic stuff, but there's a ton of jobs out there doing that. If that's more your speed or more of what you're looking to do, and more your education level, then tons of roles out there in that space for it being simpler. We also have the data engineer, and these people are a little bit more software-y than they are like science-y, but they are the ones who build the databases and the pipelines that collect data, and write the code that generates all that. So like, for example, with the contact tracing stuff for COVID, the use of the smartphones to kind of test where people who were exposed were moving. At some point, someone has to write the computer code that pulls all that data off the smartphones and sorts it and cleans it into something that can even be analyzed, because otherwise it's just raw smartphone computer geolocation data. That's what the data engineers do. All right. Sometimes I call them the plumbers of data science, because they build the pipes and the foundations and the stuff that brings the data in. And then stats nerds like me can go and explore that and build insights and models and test hypotheses and all these things on that data. So they're really important. Different skill set though. If you're much more into, you like the tech side more than the science side, and you just want to collect data, great job field. And we'll have to talk about them a little bit as we go on. And then there's also, in the last couple years, people who, again, are more on the software tech side, but they want to be hyper applied in this kind of ML AI engineer. And these are the people who focus on taking the models that the data scientists build and embedding them more directly, right? So I have engineers that work with me and under me who they take the models that my team builds, like the anomaly detection stuff I was talking about. They take that and turn it into something that's not for a paper and can actually be used by a software engine, right? right? So they have to understand how our models work and some of the basics of our logic and intuition, but they focus more on the how do you turn that into usable software, usable code kind of thing, because that's not my skill set. That's an engineer's skill set in this situation. All four of these are very thriving places where you can find jobs, and all of them pay a lot of money. It's just a matter of kind of what's up to your speed and what types of problems you want to work on. So, what skills would you need across all of them? Well, I like this chart, but one thing I want to highlight, right, is look at the data science thing and look at the skills that are very important: data visualization, intuition about data, statistics, wrangling data. Again, all skills that you've already developed in a social science PhD. In fact, I would argue most of your social science PhD and grad work is just these skills with some criminology theory and policy and practice sprinkled on top, right? But this is the core of what any trained scientist knows how to do. Yes, you have the programming and the more machine learning scaled stuff sprinkled on there because that's the role, and that's the stuff that we have to transition. We'll talk about the skills to transition there in a minute. But it's just the same stuff we're used to, and you can see for these other ones, the engineering roles focus much more on the technology side and the programming side of things. But the role of the data scientist is to be able to look at a problem and say, oh, I know how we could solve that with data. I know how we could look for data for answers of what we're trying to solve here, or that's an interesting hypothesis. I'm going to go test it to see if we're right before we make any critical decisions about it. That's the role of a data scientist. Transmission. There we go. All right. So let's set some level sets here. When I say write code, we're talking like very basic, right? In fact, I should have put this first. Your job is not in any way as a data scientist to be a software developer, to be a software engineer, to be a coder, not at all. In fact, you're not even remotely good enough to do that, in my opinion. I'm not, none of my team is. That's not what we do. Our job is to answer questions with data, right? Our job is to do science. The only reason we write code is the scale of the data we're working with, and the flexibility we need is a lot of times just outside what traditional academic programs like SPSS and Stata are capable of doing. Those are focused on someone who's working with 100, 200, 300 observations from a randomized trial, maybe a couple thousand at best. They're not designed for someone who needs to go connect to 15 different databases and piece that data together and then clean across thousands or millions of observations, fit models across, like I said earlier, hundreds of input features or independent variables. Those programs aren't designed for that. So typically, we just write the code ourselves. Now, many of you have probably already done this because that's what R is. R is a programming language that was created to do this kind of data science-y stats work. It was created in the 90s for that, of people who recognized that there needed to be a more flexible way to do this than the stuff that IBM and other companies were putting out and selling thousands of dollars. And it's open source. Personally, at George Mason, we learned R in Stats 1. It was the first tool we were handed, and then we went on to learn other tools and stuff, but it was the first tool we were handed. And I know lots of other social science departments are no different than that, is they get exposed to this. That is enough for for a lot of data science work. In fact, story thrown around conferences all the time, the Obama election in 2008, the first one of the successes of that campaign is that they leveraged data analytics. And this was 2008, so it was way before the term data science was invented. But they had a bunch of statisticians and social science PhDs who built big models that helped them assess the voter pool, specifically pulling from social media data and some other big data sources. And that was just R at the end of the day. They just wrote a bunch of R code that gathered all that data and analyzed it and crunched it. And it was really not that much different than the same R code that gets submitted for journal article papers all the time, every day in our field. The only difference is scale and what they were trying to do. They weren't trying to learn anything for an article. They were trying to win an election. It was operational. That's the kind of stuff we're talking about here with data science. So a lot of people, when I say, oh, you got to learn to program a little bit, they get hesitant and they're like, well, I don't want to go learn how to develop software. It's not at all what you need to learn. You just have to use slightly different tools that are a little bit more open, R being one of them. Python is also a really common one, and it's used a little bit more than R is, although they're both really strong on the job market. And it's much more in applied settings. Python is a lot simpler to write, in my opinion, and it's a lot easier to read, which is one of the reasons why it's caught on. And it's got a lot of packages to do a variety of different things. R has flourished in academia just because it was kind of the first to be fully stats focused. And Python is not focused on stats. It can do anything, but it's just used a lot for statistics. But yeah, these are the two main tools that are out there. And honestly, I tell people learn one and just learn it really well, and you're good to go. So if you're already in academia, all right, and we'll talk about this on my roadmap a little bit. If you're already in academia, maybe you have a research assistant role in your PhD program, or you work at a lab at the university, just start doing more stuff in R as opposed to Stata or SPSS. And that is opening you up to a skill set that could provide more jobs for you when you get out, kind of thing, if this kind of work is interesting to you. If you're not using either one, you want to invest some time to learn Python, that's worthwhile too. And we're going to talk about roadmaps of how to build skills and stuff in just a minute. While you're there, I would say there's some other things that are useful. SQL, SQL goes by different names, is the language that's used to interact with databases. Sometimes this comes up in academic research, especially if you're querying directly from databases, although we tend to mostly just kind of get our data from like extracts that have been handed to us by agencies or organizations, or sometimes Excel is our database, whether or not that's a good practice or not. Sometimes that is our database in academia. And so it's not a tool that we're overly exposed to. But all databases that you've ever heard of or interacted with use this. It's a standard thing. And so understanding how to write queries to pull data in and out of databases is really helpful, because a lot of times in a data science realm, you're more just being like, oh, here's your login to the database. All the data's there. Take what you need, kind of thing. And then you've got to go query it and extract it and do all that and get what you think is applicable to your analysis. And so that's another thing to learn, but I would say it's, B tier to learn. There's also this new thing called Julia. MIT basically looked at R, Python, SQL, a bunch of other stuff, and said they all do a little bit right and they all do a little bit wrong. And they set out to design what they called to be the scientific computing language. And it is supposed to be the thing for just doing scientists. It's kind of like what MATLAB tried to be, but MATLAB tried to charge you thousands of dollars and make money off of universities. Julia is open source and free, and so you can just download it and use it. And it's super fast, super easy to write. It is gaining significant traction. People who use it love it. I personally use it for most of my work now. It's amazing. It speaks like the way that a data person and a scientist would speak, not like how a programmer would speak. It works like we think it works that way. MIT did a great job with it. You're seeing more and more stuff like that. So as far as getting a job right now, wouldn't really help you. But it is kind of the thing that I think eventually will replace both R and Python. It's going to be the thing that if someone's doing scientific analysis in industry or academia, I think Julia is probably going to slowly take over eventually. MIT is really pushing for it. They did a really good job. So worth learning and exploring as well if you're interested. And again, like I said, your job, not to be a software developer in any way. Your job is not to learn how to write code that can be used in softwares. I've already mentioned multiple times, I have engineers who do that for me. I don't do any of that. Our job is to be scientists and to be data people. And our job is to think scientifically and answer really hard research questions just with all of this data that's out there. Only reason that we're writing code instead of using SPSS or Stata or whatever you're using is just the scale we're working. We need the flexibility and the control. That's it. That's the only reason we're writing code. And to be honest, thing that I have to tell all of my mentees, your code, if you give it to an actual software engineer, they're going to laugh at you, because we write really shitty code anyway. We're not software developers, and we own that. My job's not to, but they're going to try and do some statistics, and then it's my turn to laugh. So that's kind of like, just understand that, like, people who get nervous when they have to approach this and they see programming out here, just don't overblow what the expectation actually is in a scientific setting if you're hired for a scientific job. All right, so let's talk about the job market itself, right? So most of us in this room have masters or PhDs or will in the near future. The vast majority of data science jobs and data scientists are graduate level. And the reason for it is because that's where the scientific training happens. You don't get science training and scientific training at the undergraduate level the way you do at the graduate level. That's kind of the whole shtick. So you do see a lot of bachelor's level folks, but they typically occupy those engineering and data analyst roles and not so much the true scientific roles. Most of the scientific roles reside at the master's and doctoral level. These doctoral people are entirely folks like me and maybe some of you who got PhDs in other fields and just wanted to be a little bit more applied or a little bit more technological and transitioned over. Oddly enough, I find a ton of physicists and data scientists. I don't know why. I don't know if physics just like nobody likes doing physics, but for whatever reason, when I interview, it's guaranteed I will drink to it. I'm going to get 3 or 4 people I interview for a job that are coming from physics PhDs. I don't know what's going on. I think they should really look at that themselves. I also get a lot of economists because a lot of people get economics PhDs and they don't want to do economics. Not a lot of social science and sociology, criminology PhDs, although I am really slowly starting to change that. And that's kind of the whole freaking point we're here today. Because I do think, as you've probably noticed, a lot of the problems I'm describing are like inherently social science problems. Like you're studying people and human behaviors and human systems. And that's like literally what we can do. So that's a whole different rant. And that 1.4%, something for some reason, some lawyers have tried to transfer over, and to be honest, I don't think that's a good idea. It's not their skill set, but I've met several lawyers at conferences that became data scientists for whatever reason. But you can see this chart. This doesn't look all that different from like if I was to survey the workforce of think tanks and research centers at universities that are doing policy, social science stuff. It would probably look a little bit similar to this, right? You got your doctoral folks who are typically your seniors, your professors, et cetera. A lot of masters, research assistants, and research associates, and then a few undergrads kind of working there as well. Data science looks just like the same. So, jobs out there. This morning, I did a quick LinkedIn search on LinkedIn jobs, and I just searched data scientist and remote US, fully remote in the US data science positions. And there are currently 62,000 open jobs out there. There are currently 2 open tenure track jobs in criminology for what it's worth. So, if you're looking for a job and can't find one, this is, a wealth of plays. 5,531 of those were just posted in the last day, right? Because there's just a ton of roles out there for people who are looking to do this work. And 8,526 of them, the minimum salary on the job posting was over $120,000. And that is the highest threshold LinkedIn would let me set, right? Most of them, the minimum was a lot higher. Tons of jobs. These are high paying jobs where you get to take the skills you've learned and just apply them to these types of problems. So for a lot of people, May or a spring semester starts to bring the what am I going to do for a job? And a lot of people, maybe you go on the academic market and you're exploring academic and AltAc, and that's great. And you're exploring policy shops as well. I would highly recommend taking a gander at what's out there in the data science world for roles that you might find interesting and for companies you might find doing interesting work and see if there's something out there that seems interesting to you, right? Or something that you might want to explore more or grow skills to kind of do, because there's just a wealth of roles out there. So compensation, that's a big reason why a lot of people make the jump in data science, right? And it's the one that a lot of people ping me about, this conversation of, what do data science make? And it's a lot. It's more than you're going to make in academics, and it's a lot more than you're going to make in policy shops, just to be frank. In the tech space, we typically divide roles into individual contributors and managers. Think about this in an academic setting. Like individual contributors are your tenure track professors who they go assistant, associate, full professor, maybe run their own research center, but they just focus on research and teaching. They have no desire to be provost or department chair or anything like that. Your management track still does all that work, but they're also the ones who go on to become department chairs and provosts, and they're still teaching in academics, et cetera. But they add all of this extra businessy management stuff to it. The tech space views both of those largely equally as tracks. For reference, I know a lot of people who are on the individual contributor side who make way more than any of us in the management side do at my current company. But you can see at different levels, even these, for what's worth, these are the median salaries self-reported from this firm, Birchworks' annual survey they do of folks in this space, right? And you can see that, from looking at individual contributor side, the starting salaries, median self-reported, is around 90K right now for entry level, getting into this space kind of stuff. It's pretty high. And that's median. So as we all know, because we're all statisticians, that over half people are making more than that. And as you go up, you can get into the mid 100s, over 200. On the management side, it gets a lot higher quicker. But typically you have a lot more experience on the management side when you're, managing departments or teams who are solving bigger problems. You can see the management side a little bit kind of like a principal investigator, or like somebody who's overseeing, like a research center at the management one, and then you kind of management 2 and 3 are more like your department chair kind of folks. But yeah, the salaries in the space are big. And the reason for that is largely because there's so much data in all of these organizations, and they all just understand the fact that they could pay someone who really understands how to be scientifically rigorous. Going back to our shoe sale example, you could pay that person $200,000 a year, but if their model can help you make $3 million a year, that's an ROI anybody would take. Any MBA would take that deal. Or if you can help them save, so a lot of my projects have been more about how do we save money than how do we make money. And a lot of those, if that saves more than it costs to hire the scientist, it's worth it. Going back to the experimental stuff, testing internal policies and programs, testing things that are offered in our software solutions. If I can come in and tell you what's working and what's not working in a really scientifically rigorous way through a randomized experiment, and I can tell you here's what's worth and what's not, you shut down the stuff that's not working, you save money, I've paid for myself already, right? And so that's why these salaries are so high. They're also not grant funded, and so there's really kind of no limit on how high they can be. Whereas in the nonprofit space, you're typically grant limited, and grants are hard to come by a lot of times. And so there's a ceiling on how much money can be offered. Same in the government space when it comes to tax dollars. Industry and tech will largely offer whatever it takes, and so the money gets expensive quick, and that's great for people who are looking to make the transition. And this has also been a fairly recent thing. There was a huge jump from 2021 to 2022. And the reason for that is historically, at least my theory, is historically, a lot of the people jumping into data science came from metro areas with elite universities. They were largely in DC, New York, Boston, San Fran, LA, Houston, like places that had really well-respected universities that were shelling out masters and PhD students who wanted to get into this. And so that's where you found the people. And those people didn't necessarily want to live in Lincoln, Nebraska. And so because of that, the job market was limited. When COVID forced us all to go remote, and all of these companies in Lincoln, Nebraska went remote anyway, they realized that if they were willing to spend the money, they could hire the data scientists from New York and Boston and DC and stuff. And those people could stay where they were and work for companies all over. And that's created a lot of the explosion in jobs that I just showed you a minute ago, and a lot of the explosion in salary growth, right? Just good old supply and demand at work. And so COVID really kind of did us a favor here. And I've actually seen quite a few people on Twitter that I've known who have jumped from, they were not planning on going data science, but in the last year or two, they jumped from more of like a traditional policy AltAc space to data science just because they saw numbers they couldn't turn down, right? For problems that they liked solving, right? I would not recommend anybody see salaries here and be like, I can go sell shoes. Don't sell out just for the sake of the salary, right? Make sure you're picking organizations that work on problems you find interesting, but open yourself up to what kinds of problems you might actually find interesting. So, skill development, because 8 years of grad school apparently wasn't enough. What all ways can you add to your PhD, master's degrees that we all have to be able to get into work like this? Well, I put together a roadmap of what I recommend. First, while you're still in school, for most of us who are still in school, emphasize quantitative analysis skills in school. I personally took almost entirely methods classes for my electives because I realized years ago, while I was still in coursework, that I kind of wanted to go down this route. Emphasized methods classes for most of my electives. I took classes with the approval of my graduate director outside of our department in fields that we didn't have people who specialized in our departments. Some more computational stuff, some bigger modeling stuff. I took a class with the operations research group. They think very weird, in my opinion. That's what I learned mostly from that class. But just looking outside of traditional criminal justice scope. In your work, number 2, start to leverage R, Python, whatever tools you want to learn more, start to use those just to do your existing work, right? I highly recommend if you're in the academic or alt academic space or working at the university in a lab and the PIs that you work under will allow it, just start using R. right? There's already a robust academic precedent for doing that. You can submit R code to journals when you're publishing, all of that stuff. And it just gives you a way to start thinking this way as opposed to using SPSS or Stata or anything like that. Highly recommend starting there. Then start to look for places where you can do more applied quantitative work as opposed to doing, the theory work that we typically work on. Try and find more applied problems you can solve. And sometimes that's baked into criminology work, and sometimes it's not. Sometimes that's something that you have to go seek out to find. But look for ways that you can be more applied. Then start to develop your tech skills, right? And that is at the point where you would start to say, okay, well, maybe I want to get better at writing R code or Python code. Maybe I want to learn how databases work a little bit deeper. Maybe I want to start getting my technology skills up to speed. That is when you would start doing that. I think the thing that people flunder all the time is they jump to, I gotta get really good at programming right now. No, you got to learn how to do science really well first. Then the programming comes, right? And that's a very important order. And the people who I know who are just get into this field and they're terrible at it are because they go the other way. They start with the tech and try and learn the science later, which is way harder to learn, in my opinion. Then also find mentorship outside the academy, right? I am definitely a resource to anyone here who wants to contact me. There's lots of us out on Twitter who have jumped ship into this space and work on problems that are, adjacent to what we do. But the mentorship in the academy is not always set up for the mentorship you need in like a data science applied space. So find mentorship outside where you can. And then number 6, just never stop learning. And I'm going to give you some resources here to never stop learning in a minute. But just like there's always new methods being used in academia, there's always new methods being used in data science, and they're largely the same. So somebody put out a new way to control for variables in a logistic regression, and all the economists are losing their mind. It might be something you want to apply, right? Or maybe there's, this new clustering technique that everyone's using to find latent groups in drug trials. And you're like, hey, that could solve my problem over here too. Constantly looking for new ways that you can hash the data. In academia, people have made entire careers basically just off logistic and linear regression and use almost no other methods. That doesn't overly fly in the data science space because the problems are a lot broader and you got to start using other tools in the tool belt to analyze some of these problems. You can't really be a one-trick pony in this space, unfortunately, in the ways that academia sometimes allows people to do. And like I said, start from the top, right? Don't jump to the technology and the programming. Start from the top and work your way down. Start with building your data intuition, your knowledge about data, how to think about data, how to clean data. That's a huge one because I'm going to tell you right now, the data you get in the data science realm is shit, and you're going to have to do all kinds of work to it because databases are terribly managed at every organization I've ever talked to. So you're going to have to do a lot of cleaning. You have to do a lot of normalizing, a lot of standardizing. Not stuff that we're not trained on how to do. You're going to have to do a lot of that. So get good at building your data intuition, visualizing, wrangling, cleaning data, et cetera. That is going to be probably 80% of your job in a data science space, right? Maybe even 90% depending on where you're at. Then start really getting your statistics and modeling skills built and knowing lots of different ways to build linear models and thinking about different types of regularization you can apply to logistic regression. And again, things we use in criminology all the time. You can go to the Journal of Quantitative Criminology and read one issue of that with 5 or 6 articles in there and see all these techniques probably applied to various criminology program or problems, right? And then again, slowly building your programming and technology knowledge from there. So resources I recommend, right? 2 I recommend if you're looking to learn are these 2. And actually, let me see, I have them both pulled up on here. I'm going to, here we go. Share this. So DataCamp is an awesome organization, and it has these tracks where it walks you through in either Python or R, you can pick one. It walks you through teaching you how to code and also data analysis at the same time. And it throws in little projects where you can, solve various problems. Like in this case, looking at correlations in Netflix movies and which guest stars are in The Office are in Netflix movie winners. And going through and just doing looking at the history of various programming languages through records, studying app activity on the Google Play Store, And then it also just teaches you in these little micro courses, various things you need to do, and then little courses you can do with it. These are really great. And they're really interactive. So it's not people lecturing to you and then you got to go do it. It literally it only teaches you through making you do it yourself and telling you how you did it and did wrong, and you interactively learn through that. Great resource for people who like to be hands-on. If you want something more academic-y, edX is an initiative that was founded by MIT and Harvard together. But this is where, like, typically universities, you see MIT on here, you see San Diego, Harvard, Davidson will post. They're not like courses you would always take at the university. They're a little bit more professionally focused, but they're programs that you can learn from their instructors. So this is, MIT's little 3-course, or it looks like it's like 6 courses now. Little certificate you get here on edX from MIT. It costs about $13.50, so they're not free, but it's directly from MIT professors, and it teaches you the basics of how to do this in an applied setting, right? edX is really great. This is going to work more like a class would, where there's going to be like lectures, then you'll do a little bit of assignment and answer some quizzes and whatnot. It's outside the universities, but anybody can take these. You don't have to go get accepted to MIT to take these things and learn from these MIT professors. Those are the 2 resources I highly recommend to anybody if you're looking to get into these things, is DataCamp and edX, because DataCamp, very interactive, lets you, do guided exercises. edX, that stuff comes directly from elite universities, and you get training that your university may not be able to offer, which is awesome. And you can always apply various funding sources to that. So great places to start to just build your knowledge. Now, the thing I love about DataCamp is that not only does it give you like the basic, like, here's how you do this, but it also has it's like thousands of courses on just like one-off. So you're like, oh, I need to learn how to do time series analysis because I've never done any kind of forecasting or ARIMA models before. It just has one-offs where you can just go learn how to do that real quick, and it'll interactively walk you through how to program it, how to think about it, how the math works real quick. And you can do it in like an hour or so and learn it. That's one of the reasons why I love it, because it's easy to stay up to breath on new methods. Another one, if you want to go back to our mathlete days that many of us were definitely when we were in school, Kaggle is a place that literally hosts competitions for science. If you want to get in and build better models than everybody, organizations will host data sets. Like here, the NFL has one. They'll have a goal. They'll have some kind of problem they're trying to solve, and they will throw data up there and say, whoever can solve this problem, we will pay you prizes. And the prizes can be thousands of dollars on here. And these are free to enter. Anybody can enter them. And they're a great way to practice because it's a real problem that a real organization has. They provide the data. All you got to do is crunch it, maybe build a model, try and solve the problem the best you can, upload your results, and then whoever has the best results win. Whoever's model performs the best, whoever answers the problem better, according to the judges, they win, and you can win some real prizes. These are really fun, and they're fun things to do as just like a side thing if you want to get better at them, solve real problems. Remember my roadmap? I said try and find places to solve applied problems. Great place to start is just going on to Kaggle, entering some competitions. You might win some money, and if not, when a contest ends, the winner's stuff is all posted. So you can see, oh, the winner, here's how they solved it. And a lot of times it's because they created this metric that you didn't think about, or they controlled for this one thing no one else thought to control for, and it made their model, improve their model accuracy. And all of that gets posted at the end of the competition. So you can see what the winning models and why they were better, and you can learn from that as well. All right. I think that is it for me. Yeah. So that's everything I wanted to dump on you all. I told Shannon we need an hour and a half, and I am proving myself right once again. So I think from here on, I know there's only 12 of us in the room right now, but I will just open it up. If anyone has any questions, obviously, about anything we talked about, or just general questions about, even if it's not what we talked about, but it's something about data science or transitioning or anything like that that I can answer, open up now for anyone who wants to talk. Yeah.
Well, I have a couple, thoughts as I was listening to you, talk. One of the things that you said, right, was something like, it's a little bit like selling out. And I thought that was a really, it's funny, it's a little tongue in cheek, which I think you are, and we both are. But at the end of the day, I wonder, is it really though? Or is it just simply like finding alternative spaces to do something that you love and that allows you to explore your creativity, intellectual stimulation, that it's a bit selling out in the sense that maybe it's not directly related to the crim degree, but not necessarily unrelated from your degree.
I could not agree more, right? And I use that as a joke, and it was obvious I was joking, I hope, but like
Yeah.
could not agree more, right? One of the reasons why I've loved this space that I found for myself is I'm solving problems I never. So, like for instance, I work at a cybersecurity company now, right? That's not my specialization in criminology. If I had stayed in academia, maybe eventually I would have started working on cyber issues and found a PI who works on cyber issues. And 30 years from now, I would have written one paper with cyber related, right? But I get to work on cybersecurity problems and stuff now. To your point, even the shoe example that I use in interviews, right, is that can still be really interesting. If you're a person who just likes social science, right, figuring out who's most likely to buy shoes and why statistically might actually be kind of interesting when you start digging into it, right? There might be really interesting patterns you find there and interesting causality you determine. Stuff that there's no university that's ever going to let you work on that. That's a waste of everyone's time and grant fund money, right? But for a company who's trying to sell shoes, they'll happily pay you a lot of money to solve that. I use the sellout thing because the reality is that is a term that gets thrown out. And I have been told by, to be honest, academic professors at various universities that I have sold out on being a criminologist, right? Because that's still kind of a view in particularly social sciences around this is, oh, you didn't go become a social scientist. And I think like our field has gotten around AltAc as like policy shops and government research and stuff like that. Like that's an accepted field. And this is still the whole like, oh, but you're just going to work at a tech company. Why'd you waste your time with a PhD? I'm like, well, without the PhD, I wouldn't know how to do half of this. So that's why. So yeah, I say that jokingly, but I agree with you 100%. I don't view it as selling out at all. I think it's just a host of other problems out there that are in a different context to solve. And if you like solving social problems and you don't care where you do it and you kind of want to make more money, go for it, right? That's what this field is offering if you're willing to, make the transition to it. Just a few extra skills you got to build before you can do it. Yeah.
Totally. Someone in the audience asked, do you have any advice? And they're kind of actually ordered a bit, I feel like in a sequential order. So is there any advice or links about how to translate an academic CV to an effective data science resume? So are there buzzwords, keywords, ways to format it? I would even say like the ordering of your resume, like any advice on that?
Yeah. Don't focus on the big picture. Focus on how you solve problems, right? So on a CV, people will also often post things like research questions related to importation theory in prisons in Pennsylvania, right? Something like that. And it'll be very broad. And in an academic space, people will be like, oh, that's really interesting. What else do you work on? Where the papers, et cetera, et cetera. Screw that. In a data science perspective, focus very minutely on built, regression model based off of data collected this way, and it solved this particular problem. Be very specific. Types of methods you used, types of problems you solved, how you went about it. 3 or 4 bullet points, right? It's still a resume. You're not going to divulge the whole paper there, but just be very specific. I list stuff like Poisson mixture models and Bayesian classifiers and things on my resume because when people see that, it shows them that I've worked with a breadth of model types, right?
Mm-hmm.
Because in a data science realm, you're not being hired because you understand all of the nuances of importation theory, routine activities theory. They're not hiring you for that. They're hiring you because you know how to solve problems with data and science. And so you have to pivot in, I'm not an expert in routine activities theory. I understand how to collect a bunch of data and create this type of model about humans that can solve this kind of problem. So focus on the quantitative skills heavily, and you can kind of honestly throw out the expertise and the theoretical stuff for data science and just focus on the quant and the math. For my qualitative friends, there's a whole field out here in tech as well of like UX, UI research. It's just not what I work on. I would highly recommend Shannon and Kate get somebody to come in here and do that, but I just don't know anything about that, so I can't help you. Quantitatively, though, this field is where I'm at. So
Yes, I'm currently in the process of sliding into people's DMs on Twitter who do UX research, so we can basically have the qualitative version of Zach to come.
I do believe you have a very close connection who is in a very interesting position now, that if you
Yes,
can get them to come, that'd be interesting. Yeah.
that is the goal. Yes.
Yeah.
Um, Another person asked, could you share, and I think this is a really good question too, could you share some insights on a data science job interview?
Mhm.
It sounds like you gave us a question, right? That you asked specifically in an interview. But what other questions are usually asked? What skills are evaluated, and how might someone prepare for that kind of interview?
Yeah. So there's two types of interviews. And I've been on both of them. If you're interviewing with an organization that is new to this and just has a bunch of data and they want someone to come solve it, you're going to get asked a lot about like, what problems have you solved before? How would you go about this? Kind of stuff like that, right? When it's like an MBA interviewing you. When it's another scientist interviewing you, it's almost always going to focus on the stuff I just mentioned about a resume. I had one dude, so I interviewed a few months ago when I was in the job market before I joined Newspire, and he was a physics PhD, but broke away, a decade ago, and now he was doing this stuff. And he asked me specifically, he said, pick a model you think you know well. And that's never a way to start. But I was like, sure, we'll roll the dice here. So I was like, let's go with logistic regression. And he started pegging my knowledge about like assumptions of independent variables and that, and how you would control in a regularization sense, and what does L1 and L2 ridge and lasso regularization actually do, and what is the results, like very specific, kind of like honestly like a stats 2 midterm kind of stuff, right? That wasn't pass fail, right? Like to get the job, it wasn't like you got to know all of this. He was just prodding the depth of like, how much do you understand this? Because to his credit, and I've started doing some of this myself too, to his credit, when you get into the real space, is you're not submitting this stuff to peer review. No other scientists other than your own team, but there's not going to be this like blind panel of scientists that says, hey, you forgot to control for this, so this isn't good, right? You're going to hand this stuff over to engineers or MBAs who don't know jack anything about this, and they're going to run with your results and say, oh, no, don't worry, our scientists figured this all out. This is it, right? So you really do have to be really good about thinking through the limitations of your own model, which we should already be doing in an academic space anyway. But for any of us who have ever peer reviewed anything before, know that not everyone does. And because of that, like that's a really important skill, is really thoroughly understanding how these models work. And so finding a handful, linear and logistic regression are the easy ones, and just really deeply understanding limitations and assumptions and controls and all of the stuff that go into those is probably something that a place is going to ask you, right? You'll probably get some questions that are technical too, about programming and databases and stuff, and that's the skills that you have to add here, right? That's and no punches pulled on knowing that. That stuff, I think, depending on where you're at, you can be pretty frank about where the limitations of your skill are, right? I think some people, I've interviewed people before who've come in and they have to come off as this like expert programmer as well as this like statistician. I'm like, bro, I'm just trying to make sure you understand how to write some basic reproducible code here, right? That's it, right? And so be honest about your limitations there. Some shops will be more into that, right? Especially if, depending on what they need from you, they might be more stringent about how much of a programming skill you have, and others will just be like, yeah, as long as it's something someone else could pick up and rerun for reproducibility, that's fine, right? And those are two different skill sets. And that's about finding the right fit of an organization for you, and be frank about that. Don't shoot yourself in the foot and act like you're a software engineer and then get in there and have no idea what the hell you're doing. You'll regret that, and they'll regret that, and nobody wins in that situation.
So thinking about that, and please, if anyone else has any questions, feel free to unmute or to use the chat function. It sounds like the world is your oyster, so to speak, but are there places where this is happening more often?
Yeah.
That you could maybe start at least Googling, start learning more of their job postings, just kind of follow them to get a sense of who they are as a company.
Yeah, and this is how I got my start, as you mentioned earlier. For people who are coming from policy, social science places, the big government contractors are just a wealth of data science jobs in a government policy applied space, right? To get in and learn. And while they all kind of suck for various reasons, which is why I don't work for them anymore, they have advantages in the fact that they are large and have lots of money and lots of resources for you to grow and people to learn under, right? So if you were to go to a 3-letter name or a 1 letter with a little dot after it, or a 1 word with a dot after, pick your, big government contractor and work there for a little while, you'll get exposed to a lot of different problems. You'll get to work in a setting that's very closely related oftentimes to your degree, because you can usually work in something like a DOJ, a DOD, a DHS applied setting, doing something, justice or homeland security related. And it can be in a very data sciencey realm, and you'll have opportunities to mentor. I think it is my personal opinion, and I'm sure lots of people would disagree with me on this. It's my personal opinion that it's a bad idea to go to a small business or be the first data scientist at a place when you're just transitioning out, right? So for instance, I'm the first at my company, right? They're pivoting and want to be more data science driven. And so they brought me in to build this team, and now I'm hiring and doing all this stuff. Nah, because even I feel overwhelmed, and I've been doing this for 9 years now, right? So like definitely would not say that's a good place for someone to get their start unless you're working under someone who can mentor you and grow you in that, right? But the big firms, great place to start. Also, in like big consulting, so your big four, your Deloitte, your KPMG, your PwC, like these big consulting firms, a ton of this stuff. And they do a ton of data analytics to hire for your Ford and your Fortune 500 companies, ton of that stuff. Great places to grow. You got to work with MBAs, which is a whole thing that none of us will ever enjoy. But you'll get to learn stuff there, right? In ways that is just, you won't get to learn in smaller shops. And then you can go solve the world's problems that you're interested in, right? But they provide you a great starting salary, a place to grow, and they have so many open jobs that it can often be easier to get your foot in the door at a junior level at those kind of places, right? So that's my recommendation. If you're not in the DC area, the government contractor one can be harder, although it's not impossible because they are pretty spread out throughout the country. I know depending on largely how big of a military footprint your state has is kind of how big their government contractor space is. But yeah, I mean, on the government contractor side, one of the coolest projects I got to work on was with Medicare and Medicaid, building models to detect fraud in the like the bills doctors sent in, so we could catch doctors who are defrauding the Medicare system or selling pills under the hood with Medicare money, stuff like that, right? As a very criminology focused problem, right? But we just built statistical models with the data that is the bills being sent into Medicare, and those are now sitting on a system IBM manages for them, and they just flag stuff that goes to investigators, right? And that's an application of our skills that I got to use.
I will also note that while Zach kindly uses some terms to describe consulting firms, that there are pros and cons to every industry space.
Yes.
And if you'd like to know more about those pros and cons, you can also see Zach's older conversation on
the last time I was here. Yeah.
Talking about the pros and cons of consulting spaces. But the cons typically tend to be that they you work a lot of hours. It's fairly fast paced. The turnover of your projects is a bit faster than other places. So just an interesting take on the world of what you're interested in, but a really great starting place. And a lot of times people will start in consulting firms like Zach's talking about and use that to leverage legitimacy in smaller shops, or to move to other places where they want to answer questions that they really want to answer. When you have the legitimacy of a large consulting firm on your resume, sometimes that can give you a leg up. So thinking about ordering of events, I've been encouraged to do consulting before going on to do something I really wanted to do. With that, someone asked, how do you find mentors in the industry outside of academia? Do you cold email people on LinkedIn? What should you expect to get out of a mentorship? So a really great question.
Yeah. So depending on what metro you're in, if you're in a rural area, it's a little harder. If you're in a major metro area, look for local meetups of like data science groups. They're real common in the tech space, right? And so there'll be small groups that just do meetups. They're kind of like mini conferences, right? So maybe like one person will present something like this, and there'll be like coffee and donuts, and it's just like a networking thing. They're real common in the tech space. Almost every market will have them. Just start showing up at those things, right? They're almost always free to attend, and they usually have like an Eventbrite or something to pre-register or whatnot. And you can just show up, meet people, talk to people. Be honest, like, hey, I got a PhD in criminology, trying to transition. You'll probably find a ton of other people who got PhDs, an abnormal amount in physics, and then they'll, probably be like, oh yeah, and they'll have this conversation with you over, coffee and donuts and stuff, and you'll meet friends there. It's a great way to get in. LinkedIn works great too. You can usually find stuff. I have several mentees that are just people who ping me on LinkedIn. And they were just like, "Hey, I want to pick your brain." And now, several years later, they're still, mentees of mine to some capacity. That depends on the person, how receptive they are, and how much they enjoy that, right? So not everyone's going to respond, and some people tell you to f off, and that is just part of it. But a lot of people, in my experience, will probably take the time to at least talk to you, for a little bit. Um, to establish a long-standing mentoring relationship sometimes just takes time and the right person at the right time. So that's hard to find. But yeah, the meetups are the one I recommend, right? And you also get to learn things because typically at those, someone will present something cool they're working on, right? And you get to learn things like a little mini conference in like an hour. So look for those. Just search data science meetups on like Eventbrite or LinkedIn or something like that, and you'll find a ton of them. So I want to go. Can we go back to a question real quick? Well, sorry.
Yeah.
Let's finish this, then we'll go back to a question that we skipped. Yeah.
Yeah. Well, there's one last question on
Okay.
here. But I was going to say to add just to that point is I have also slid into the DMs of people on LinkedIn, and said, hey, can I talk to you? In my experience, most people who have transitioned out of academia, and I think it's one of the pros of the AltAc culture, people are a lot more giving. In my experience in the AltAc culture, people want to help each other and elevate each other. It's one of the reasons why I love this space a little bit more. It doesn't feel as competitive in my experience. And so in my experience, people, even a cold email or a cold DM gets a lot of response of saying, hey, I'm interested. And if then they don't take it personally, keep it moving, send the same email out to multiple people. Another question that's on here is, how do you, this is a lot and it might feel very overwhelming and you're not sure you're good at it and you don't know if you want to do it. And so before you fully commit to this, are there ways to kind of put your foot in the door, to kind of like drop your toe in and say like, oh, do I like this? Do I not? Are there part-time positions to kind of understand what it's all about?
There are internships galore. They're not always going to be paid, to be honest, right? But there are internships galore. There are paid ones, but they're extremely hard to get, right? And that's typically people who already know someone, especially in the big tech space. But they're out there. So there are unpaid internships. In your smaller places, if there's the right mentor, they'll typically not like have an internship program, but take on interns, right? So like I personally have, we'll take on interns wherever we can in my role. Kind of in cycles, we'll take a few on because we can't pay you, but if you just want to mentor, right, and kind of work alongside me, but in that case, we're respectful and we don't just dump work on them and say, here, this is yours now, do it for free. That's not how we do an internship. It's more like, hey, you want to work with me on this to learn. Not everyone will treat it that way. But I can't stress enough how much you'll learn by just doing like the projects I mentioned, right? So if you go through the data camp thing, you just do those little projects, you get exposed to the type of work quickly of like, oh, this was interesting. I like doing this, or doing the Kaggle stuff. In the real world, like the organizational BS around it is a drain, but that exists in academia and government and nonprofit and tech. And no matter where you go, the organizational BS we all have to operate in is a drain. So, that's kind of a standing thing. Some places are just better than others, but you can't really test for that until you're there. Organizational culture is hard. But knowing whether you like the work or not, you can test by just doing these projects. And I argue you can build a portfolio around that real quick of things that you've solved, and then you can use that in interviews, right? And so if you don't have a lot of data science experience, but let's say you do the data camp thing and you do all the projects associated with the course, or you do, Kaggle and you just, compete in a few competitions and you submit a few things, you use those in your interviews to talk about ways you solve problems and ways you went about it, right? And it gives you a portfolio to work from that's different than your academic portfolio, and you can list some of that on your resume too. So I really recommend those because they're really just fun. You can do them at night, in your free time, kind of ways to just hack through some data and see if you can solve a problem and learn and stuff like that.
Awesome. You said you wanted to go back to a question?
Yeah, Ben, you asked a question that we missed, sorry, about how
Oh.
important is the abstract mathematical skills, right? Multivariate calculus, linear algebra, et cetera. So we don't talk about this enough actually in social sciences, but fun fact, when you fit a logistic regression model, whether you're using SPSS or Stata or R or whatever you're using, linear algebra is used under the hood and calculus to actually fit the coefficients, right? That's how it computes the model. One thing that you do, and this goes back to a point I made earlier about understanding more deeper about like how these models work, is sometimes understanding how the computer actually fits the coefficients is also valuable for the problem you're trying to solve. And that's where that stuff comes in, right? So you're never going to need to go take the derivative of something yourself. That's not the types of problems we work on. But it might be helpful to have a general understanding of how the underlying calculus of fitting a logistic regression model works. Right. And how optimizing a loss function works and all of that stuff. Things that actually, oddly enough, Su-Ming Yang, who taught my Stats 2 course at George Mason, did hit on that stuff, oddly enough, because some people in social sciences do understand how that works, but it's not the norm, right? And so a lot of times we just say, here's logistic regression, here's how you interpret the coefficients, here's how you run it in R, here's what the output means, and that's all we go with. In the data science space, sometimes we have to get more customized in the way we solve problems. And so you do have to understand that. For instance, I was working on a project a couple years ago now that was using mixture modeling in a little bit different way than I'm currently using it. And the way we wanted to apply it, none of the existing R or Python packages did it the way we wanted it to. So we actually had to just go write it ourselves from scratch. And in that situation, I had to write a little bit of linear algebra code and a little bit of optimization code myself. And I had a guy who had an actual degree in like actual statistics. That was a little degree. So he was like really helpful in this. So we had to dig into the calculus and algebra a little bit doing that, but that's rare, right? And that was a very specific case we had to solve that we just had to go learn. And in that situation, you just go to YouTube and you look up a 3 blue, 1 brown video on how to do it, and then you're good to go, right? And so that's all you need to know. I've never in an interview had calculus or any of that stuff show up, but you have to understand that all the stuff we're doing statistically is built on top of that stuff. And that's the only place it ever comes up.
Yeah, I think that's a super important point. And I want to acknowledge that Kate also in the chat, mentioned going kind of back to Allison's questions about internship or where can you kind of dip your toe in the waters, that there's, volunteers, you can look for places, volunteers. It is, I will say, my organization is currently about to burst with the amount of new grants and data we have, and we don't have enough scientists to do it. And so we are in the process of about starting to hire a significant amount of part-time employees to help us get through the data. But it is so, if you have an agency that's near you, go knock on their door, say, hey, I know that you probably can't pay me. I understand that not everyone has the ability to take a position that is unpaid. So I hear that. But say, I can do this work. I'm really interested. Can we set something up? And then working, I know several people who have been able to build their own internship by knocking on a door and asking, hey, can I help you? Do you need help? Lots of particularly corrections agencies have lots of data and not a lot of scientists, because as a discipline, criminology hasn't trained scientists, which is in part why we're here, to go to AltAc spaces. So they have lots of questions and they can't find, or they haven't partnered with researchers yet, or a researcher in a university won't do it unless it has grant funding, right? And we understand all the dynamics that creates, or why that exists. Then knocking on the door and saying, hey, I will help. I have 2 hands and I already have access to whatever R, Python, whatever it is, I would get you very, very far. You can also, in the knocking on the door, also negotiate, here's it, I'll do it for free, but I can use this data for a thesis or for my dissertation, or can I write off of it? You can start negotiating your own place in that. And those things in them of themselves are a skill that you can go talk about in a job interview. I negotiated my own access. I know how to work with partners. I know how to advocate for myself in these ways. Those are all important skills to learn in AltAc spaces and in university spaces. But
absolutely. Yeah. On the tech side, by the way, the whole saying that how to build partnerships and whatnot, massive, because even when you're entirely internal facing, you got to work with internal departments, you got to work with other people, you got to go talk to the MBAs every now and then. And so showing that you know how to like work with people outside of just your own little scientist bubble is a really big, like a soft skill that gets overlooked. And honestly, not one that there are career tenured academics that never have to talk to somebody outside the university, right? Because they collect their own data, they have their own grant funding, and that's about it. And that just isn't going to fly in anywhere that's not, Ivy Towers. So
For sure. I know that we're about to reach the bottom of the hour. Are there any other questions for Zach? Kate, anything from you or anything I forgot?
No, this was really eye-opening. I learned so much. Zach, first of
Wow.
all, you're hilarious. I
Thank
almost
you.
broke my laptop a couple times, quite literally spitting my tea out onto it. But no, seriously, I learned so much. I might be knocking on your door at some point in time to figure out how to kind of talk about some of my skills in this way. Not that I'm looking to transition out of my position, but just think about, different ways to talk about these skills. And I've always said, I'm weirdly interested in prisons, but I could take my skill set anywhere and be very happy doing the science work. And you've really suggested to people how that's like 100% accurate, just in completely different space, instead of an agency evaluation, performance evaluation, policy evaluation perspective, taking it in this kind of science for good. I really like how you said that at the beginning as well. So thanks again for your time.
Absolutely.
Again, twice now. It's like a rock star repeat, redux. So cool.
It's not going to end, right? Y'all ain't getting rid of me.
No, everyone
Number
probably
three
get on a bandwagon of some kind. This thing is really bothering me. Let's talk about it. Okay, let's talk about it. I really appreciate your time, and everyone else for joining Zach and joining us. Your email will be accessible to students. I will send that out, as will this recording. So if you've registered for this session, you were added to the calendar invite, we have your email. You will receive an email with all of the information, including the presentation, Zach.
Yeah, that's fine. Yeah.
I can send that out. Okay, perfect. So
Yeah.
I'll send out the presentation. You'll have a link to this recording if you want to go back to it, share it with colleagues and friends. And then you'll also have Zach's email to kind of get in touch with him and talk through. Encourage you to do so. He's a wealth of information, has worked in an incredible amount of spaces to tell you and compare the differences between them. So I think it's certainly worth knowing this rock star. I like, Kate, your rock star repeat. I wish I would have thought about that sooner. And so I really appreciate everything that you've offered here.
Absolutely. And to add to that, don't send this in the blast to 162 people. But for anyone in this room going to the mentoring thing, if I can be of a direct assistance to you, just ping me on LinkedIn or something, and I'm happy to coach as many people as I can over to this. So, I know Shannon mentioned you have my email. From me personally, feel free to knock on my door, and we can help you however we can. So.
Awesome. Thank you. Kate, any other last words?
I guess I'll just put in a plug for the session that we have next week. I think there's one on either Tuesday or Wednesday. Maybe I should look at my calendar before I say that. Maybe it's
Tuesday.
1 p.m. my time in the Pacific Northwest. So I guess that's 4 Eastern time zone. Tuesday the 25th, we are talking about what to do with your dissertation. And then the following week, Thursday the 3rd, I'm going to chat about kind of different AltAc spaces and kind of take it back to one of the first presentations that we did about 2.5 years ago. I can't believe we've been doing this for a while now. And just kind of chat about all the different places you can do this really, really cool work that's, fully academic, fully informative, and methodologically rigorous and everything, just outside of the walls of the ivory tower.
Absolutely.
I think we're good.
Yeah, sounds good. Thank you so much, guys, and have a good rest of your day.